back and see the meeting again. All right. Let's begin with the little review. All right, complex numbers. What are complex numbers? All right. The imaginary unit I is a number such that I squared equals -1. This is the definition, the stone in which we're going to build our mathematics of complex numbers. Whenever we find an I to the 2, I to the second power, that is going to be equal to -1. All right? This is the idea of a complex number. Now we know there cannot exist a number that elevated to the second power gives me a negative number. We know that. How do we know this? Simply because of the properties of the exponents. Remember that if the solution is always going to be even as well. I'm sorry, positive, right? So there cannot be a number elevated to the second power that gives me a negative number. That cannot be in the real numbers. This is why these are called complex numbers, something a little bit more interesting than the real numbers. All right, beautiful. So complex numbers and the imaginary unit come from the solutions to second degree equations with a negative discriminant. Remember, second degree equations are called parabolas, right? Are called second degree equations. Man, I forgot the name of those. Parabolas. Damn. I forgot the name. Whatever, let's continue. And some of those have a discriminant that is negative. Remember, you can always find the discriminant of an equation. A quadratic, there is the word. You can always find the discriminant of a quadratic equation, which is b squared minus 4ac, the thing inside of the root, right? So some of those are negative, meaning they don't have a solution, right? Okay, but if they don't have a solution in the real numbers, they do have a solution in the complex numbers. Here's an example. We have our second degree equation, so our quadratic equation, right? And to solve this, all we have to do is apply the quadratic formula. Remember, this is negative b plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a. Simply replace by the values. Beautiful. If you do so, we will see that the discriminant is in fact negative. The discriminant is the thing inside of the root. So in this case, 1 squared minus 4 times 1 times 1. This little mathematics in here, this little calculation is absolutely simple. This is 1 minus 4, right? So inside of the root, we have a -3, meaning the discriminant is negative. -3, a negative number. So this does not have a solution in the real numbers, but it does have a solution in the complex number. We're going to create new numbers that let us calculate the square roots of negative numbers. The solution in this case will be here. -1 plus or minus the square root of 3 over 2. Simple. Square root of -3, sorry. But this -3, we can split it. We can split it into square root of -1 times the square root of 3. Remember, you can split the roots if inside of the root there is a multiplication and you are multiplying. You have 3 times -1, right? 3 times -1. This is -3. So you can split these two. And square root of -1 will be I, right? Our imaginary number. So there we go. We have our two solutions now. Before this, we didn't have a solution. The answer will be no answer, not solution, not possible. But now we do have a solution, right? Beautiful. I'm doing this a little bit faster because this is a review, right? We can watch a video about this information, but we don't need it, right? Now, there are some powers of I. And just like we see in the class, these powers repeat. So I to the 1 means I to the second means -1, I to the third means I to the fourth means 1. And then it will repeat again. I to the 5, the 5th is I. I to the 6th is -1. I to the 7th, -1, negative I, and I to the 8th, 1. Then it will continue to repeat. Now we use this information to solve questions like this. How much is I? How much is I to the 18th? All right, I to the 18th can be split into I to the 16th times I to the 2nd. And why did I choose to split it like this? Simple. The 16th, this exponent can be expressed as 4 to the 4, right? Because you can multiply these two because of the powers of the exponents, right? So 4 to this I to the 4 to the 4th means 4 times 4, which is 16. Beautiful stuff here. And we know the solutions of this. We know how much is I to the 4th power. Look, I to the 4th power is 1. And we know how much is I to the 2nd power, which is -1. All we have to do is replace. So we have 1 to the 4th, which is 1 again. 1 times whatever is that whatever. So I to the 2nd power is -1, meaning the solution is -1. Beautiful stuff here, right? Okay. Now, let's jump into the beautifulness that is complex numbers. This is a simple definition of complex numbers. Every complex number is in the form of a plus bi. Remember, a and b are two numbers, right? A is called the real part, and b is called the imaginary part. You guys remember this? We saw this in the last class, right? And what is I then? I is just the imaginary unit that we saw in the beginning, right? Here are some examples. I'm going to do some examples later. All right, sum, addition of complex numbers. Beautiful. What if we have one complex number here, a plus bi? This is a complex number. And we're going to add it. We're going to add this complex number to another complex number. How do we do that addition? How? How can we add these two complex numbers? Absolutely simple. We're going to take the real part with the real part and the imaginary with the imaginary. In other words, do like terms. Real with real, imaginary with imaginary. Here, an example. 3 plus 2i is going to be our first complex number, and the second is going to be -7 plus 4i. All right, how do we add these two? All right, first, just like in our little formula here, we're going to locate the real parts on each number. Now, the real parts are the numbers that don't have the I, right? The ones that don't have, that are not a coefficient. So 3 and -7. These are our real parts, and we're going to add them. So 3 plus -7 is going to be -4. There we go, -4. And then we're going to add the imaginary parts. So 2 is the imaginary part in the first complex number, and 4 is the imaginary part in the second complex number. So you have 2 plus 4. 2 plus 4 is 6, and the solution will continue having an I, right? These are like terms. So 2i plus 4i, 6i. Beautiful. This will be our solution. -4 plus 6i. Beautiful stuff here. So simple. But how would you do a subtraction? How would you do a subtraction? Okay, well, it is exactly the same. It is exactly the same. It is exactly the same. Simply subtract the real parts and then subtract the imaginary parts. That's it. That is it. Here's an example for it. All right, here we have our two complex numbers. The same complex numbers that we had before. The only difference is that now we are subtracting these two complex numbers. So how do we do this? All right, take the 3 and take the -7, the real parts, and we are going to subtract them. So 3 minus -7. Look at that. We have a minus and a negative. 3 minus -7 will make it so that this is positive, right? So 3 plus 7. The first part then will be 10, positive 10, right? 3 minus -7. That is 10. Beautiful. Now with the imaginary, 2 minus 4. Okay, how much is 2 minus 4? Okay, 2 minus 4. Well, that is negative 2, right? And here it is. Negative 2i. Again, carry the I because we are subtracting like terms. 2i minus 4i will be negative 2i. Beautiful stuff. Here we have our subtraction. All right. How about multiplication? Can we multiply products? Can we multiply complex numbers? Yes, we can. Yes, we can. Here, we have one complex number multiplied by another complex number. How do we do that? We are going to use FOIL. Now, in the chat, please. I know what FOIL stands for, but do you? Write in the chat, please. Let's see how many of you got it. Okay, you don't have to write yes. You have to write the definition. What is FOIL? All right, Sara Jimenez. First, outers, inners, and last. Beautiful. Maria Paz Penagos is writing it, and there we go. She did it as well. Beautiful, Maria Paz. All right, thank you, Ethan. You did it as well. Yes, this is firsts, outers, inners, and last. Same as Parrado. Parrado got it as well. All right, so let's do this with an example. Let's take our two numbers, and as you can see, I'm using the same two numbers. Look, 3 plus 2i, negative 7 plus 4i. 3 plus 2i, negative 7 plus 4i. 3 plus 2i, negative 7 plus 4i. Man, I am so good at this. I am doing the same number, huh? All right. Let's take this multiplication little by little. Let's do FOIL. First, let's do the F, which stands for first. So take the 3 and the negative 7. 3 times negative 7 will be negative 21. All right. Let's go with O from outers. So 3 and 4i. 3 times 4i. Okay, that'll be 12i, right? Beautiful stuff. Let's continue with the I, which is inners. In this case, 2i and negative 7. Inners. 2i and negative 7. All right, 2i times negative 7 will be negative 14i. Here it is, negative 14i. And last but not least, the L, which stands for last. So the 2i and the 4i. And you're going to take this as multiplying any other sort of polynomial. So 2, if you had 2x times 4x, you would have letters with letters and numbers with numbers. So 2 times 4 will be 8, and x with x, which will be x squared. In this case, we have an I, but it is exactly the same. I times I will be I squared. Remember, numbers with numbers, letters with letters. Beautiful stuff. From here, can we do something else? Well, yeah. Yes, we can. Right? We recognize that here, we have an I squared. This I squared is the definition of our of our imaginary unit. Remember, every time we find an I squared, this is a negative one, right? So instead of having positive 8 times I squared, we have 8 times negative 1. Beautiful, Richie. Yes, you got it, my man. So this will be negative 8, right? And if we do like terms, we have negative 21 minus 8. Negative 21 minus 8. All right. Then by doing like terms here, we can do 12 minus 14 and then carry the I. 12 minus 14 and then leave the I. Negative 21 minus 8 will be negative 29. And 12 minus 14 will be negative 2. Carry the I as well. That's simple. Now, as I said at the beginning, this was a simple review because since you guys came back from the break, I'm assuming you guys probably forgot about this. I'm making this review to kind of get you in the mood of doing some complex numbers calculations, right? Because what is about to come? We're going to do division of complex numbers. Before we do division, let's try to do, we need to know what is the definition of a conjugate, right? All right, let's begin with the first part. Let's say that we have a complex number, a plus bi. This complex number, we're going to name it z. So z is our complex number, right? Z is a complex number. Then how do you find a conjugate? All right, the conjugate, which is denotated Z with a little line on top, Z bar. This is how we call it, Z bar or Z conjugate. Z with a little bar on top. Now, why am I saying Z? Because here is a Z, right? That is the complex number that we're finding. Z is the complex number, so Z with a bar. That is how you denotate it. This is notation. This is writing properly in mathematics. So from now on, whenever you find a complex number with a little line on top, you know we are talking about the conjugate. But how do you find the conjugate? This is notation. This is not how you do the conjugate. This is how you write it. But how do you do the conjugate? Absolutely simple. The conjugate of a complex number is the same number, but instead of one operation in the middle, you're going to change that operation. If it is addition in the middle, you're going to have subtraction in the middle. If it is subtraction in the middle, you're going to have addition in the middle. Huh? To make this a little bit clearer, let's make an example. All right, let's see how many of you can find the conjugate of this complex number. Our complex number will be x. Can you find x bar in the chat, please? Okay, then my turn. All right, Parrado got it. Parrado got it. Maria Paz Penago got it as well. All right, I'm assuming you guys are thinking, all right, this cannot be that easy. It is. Simply change the sign in the middle. That's it. The real part of the complex number will carry on. The real part is the same, but the imaginary part will change its sign. Look, the imaginary part in x is 2, right? That is the imaginary part, 2. Positive 2, in fact. So the imaginary part in the conjugate will be negative 2. Change the sign of the imaginary part. That's it. That is it, guys. That is it. All right, let's see how many more people in the chat got it. Also, Sara Galvis and Sara Jimenez and Lunita. Beautiful, guys. How about this? Can you guys do this one now? Let's see in the chat how many of you got the answer of this. Can you find W bar? Yes, sir. All right. The solution. Carry the same real part, so -7 is the same, and the sign in the middle is the one that changes. So the real part was -7, we carried that, but the imaginary part was -8. So we change it, and it's now going to be +8. That is it. All right, let's look at the chat. Let's look at the chat. Sara Jimenez and Maria Paz Penagos and Parrado and Pardo. Salome and Maria Emma. All of you got it correctly. Beautiful. Richie saying, profe, ¿por qué cambia el signo? No entendí. ¿Me lo puedes volver a explicar, por favor? Yes, sir. Look, we are trying to find the conjugate. Look, these are not the same number than this. Can you spot the difference? X and X with a line on top. This line on top of the number means the conjugate. And how do you find the conjugate? By changing the sign. That's it, brother. That is why the positive here changes into a negative. The negative here changes into a positive. That is it, because we are looking for the conjugate of the number. All right, is that better, Richie? Beautiful, beautiful stuff. All right, guys. No, don't worry, my friend. I'm here for you, dude. Just go ahead and ask as many times as you want, all right? All right, let's see. Guys, if you think this is simple, we can improve this a little bit longer. How much would be the multiplication of any complex number? Remember, this is a complex number. We don't know the values. We don't know A and B. So this stands for every single possible complex number. What happens when you multiply that number by its conjugate? All right, let's see. When you multiply it, you have to do FOIL, right? You would have to do FOIL. That is how you multiply complex numbers, right? Z is a complex number and Z conjugate is another complex number. So we are multiplying two complex numbers. And as we saw in the review, we have to do FOIL, right? So we do firsts, which is A and A, right? A times A squared. Then we do O of outers, which is A and BI. A times BI, which is this one over here. A times negative BI, right? So that'll be negative ABI. Here it is, negative ABI. Beautiful. Now let's go with inners. BI times A. BI times A. Well, that will be ABI, which is this one over here. And last, BI times negative BI. So positive times negative is negative. And BI times BI is BI squared. We just did FOIL. From here, let's try to cancel the things that we can cancel. Here, the I squared is a negative one, right? So instead of having negative B squared, we have positive B squared. Positive B squared, right? And these two values are the same, so these get canceled. So by multiplying any complex number by its conjugate, we are going to have A squared plus B squared, effectively canceling the complex unit, the imaginary unit. I feel like this is better explained with an example, right? So let me change into the board. There we go. Let me change it to the board. All right, these were topics of the last class. I was with 11th grade. So then look at this. You're going to see this eventually, guys. All right, let's do an example. Let's do an example. Focus camera, thank you. All right, let's say we have our complex number Z. Will be 3 plus 2i. Now, the conjugate will be 3 minus 2i. Is that correct? So far, so good. Wouldn't you agree? Okay. So, what would be the solution of multiplying Z times the conjugate? Yes, yes.
Un 2.
What?
Donde dice y z igual a 3 más, ¿eso es un 2? ¿2i? O sí,
yes. Let me do it a little bit bigger then. 2 and 2. Is that better?
Yes, mister. Thank you.
Beautiful. All right. Beautiful. So, to multiply these two complex numbers, to do this multiplication, we're going to have to multiply them, right? So we have 3 plus 2i times 3 minus 2i, right? That is the idea of multiplication. Okay, so how do we multiply these two? Can any one of you do it? Let's see who's faster. You guys try it and write the solution in the chat. I'm going to try it as well. From here, we're going to have to do FOIL. FOIL, right? So let's begin with the F first. 3 times 3. That will be 9, right? Oh, outers. 3 times negative 2i. 3 times negative 2 is negative 6, and then carry the I, right? Let's continue with I from inners. 2i times 3, right? 2 times 3 is 6, so we have positive 6, and then carry the I. 2i times 3. Beautiful. And L last. So we have 2i times 2i. 2i times 2i. But look at this. Positive and negative. We have this positive and negative. Positive and negative will be negative, right? 2i times 2i will be 2 times 2, 4. And I times I squared, right? Beautiful. Did we finish? No, we did not, right? We did not finish. We can do things because you guys remember that I squared is negative 1, right? So what we have here is, oh, look at this. Negative 6i plus 6i. These two are 0. These two get canceled. 6i plus 6i. Look, negative 6i plus 6i. That is a 0, guys. Huh? That is a 0. So we have 9 and then minus 4 times negative 1. That is what we have. Minus 4 and the negative 1, which was the I squared. But that can be solved as well, right? This is 9 plus 4, right? Of course, this thing will be 13. Effectively canceling the letter I. There's no longer a letter I in here. It disappeared. Huh? So beautiful. Now, that was exactly what I was trying to show you in here. Whenever you take a complex number and you multiply by its conjugate, you will have the first element, a squared, and then the second element, b squared, with an addition in the middle. That's it. A squared plus b squared. Always, no matter what complex number you are using, if you multiply it by its conjugate, the solution will be I squared plus b squared. All right, let's go back and see how many of you got the answer. All right, 13, 13. All right, beautiful. Richie, and Maria Paz, and Carlos. Carlos, I thought you didn't come. Beautiful, brother. Lunita, Maria Emma, you guys are great. But can you do even better? Because now we know the little trick. Now we know that instead of having to multiply all of that, the multiplication was the first digit square, 3 squared, plus the second digit squared, 2 squared. This will be 9 plus 4, which again was 13. Look at that. Instead of having to do FOIL, I was able to do just that. But that only happens when you take a complex number and you multiply by its own conjugate. If you multiply by a conjugate that is different than this one, a different conjugate, then that will not work. All right? You have to take a number and multiply by its own conjugate. Yes?
Of this will be the quiz? Bueno, the classwork?
Yes, sir. This and a lot more. This and a lot more. Yes, sir. All right. Let's see how many of you write in the chat the correct answer. We have -1 plus 3i multiplied by -1 minus 3i. How much is that, guys? How much is that? I don't know if you guys can see. -1, -3. Yeah, a little bit better, right? This is an I. Okay, somebody got the trick. All right. Beautiful stuff, Sarah. Beautiful stuff. Nobody else, guys? Please don't tell me you're doing FOIL now. Please. Don't tell me you guys are doing FOIL. Because in here we have a complex number being multiplied by its conjugate. Look, plus and minus. This is its conjugate. So you can apply the trick that we just learned, right? Beautiful stuff, guys. Beautiful. You guys got it. All right, so we know the solution will be a squared plus b squared. In other words, -1 squared, so -1 squared, right? Plus b squared, so 3 squared. We have 1 plus 9, which is 10. Man, look at that. So simple. And here is the reason why somebody in mathematics decided to create the conjugate of a complex number. Because it's a number so special that when you multiply it with the original, you eliminate the letter I. Always. No matter what complex numbers you multiply, the solution will not have the letter I. So good. All right, let's look at the chat. Sara Jimenez and Oriana, Maria Emma and Lunita and Sara Lucia. You guys got it correctly. Beautiful, beautiful guys. Also, Richie is asking, profe, una pregunta. ¿Cómo se llama este tema en español? Números complejos. ¿Listo? Números complejos. Esta parte específicamente es operaciones con números complejos. Vimos suma, resta, multiplicación y estamos viendo el conjugado. Así, ¿listo? Conjugate, conjugado. ¿Listo? Y aparecen los ifs, es probable. No te quiero decir sí o no. Es probable. Es un tema requerimiento del país. El país dice que tú debes aprender esto en noveno. Así que yo creería que sí. All right, let's continue then. From here, we can go back to our presentation and see a little bit more of this. All right, so here we have some examples. Do not do these examples, please. Do not do these examples. We're going to do them eventually, but not today. And now, let's begin with the important part of today's explanation, how to divide complex numbers, right? Now, dividing complex numbers means the same as writing numbers in standard form, all right, guys? So please, if you are writing notes in your notebook, go ahead and write it down. Writing numbers in standard form is the same as dividing. If I ask you in a quiz, write these numbers in standard form, you know you have to divide them. All right, guys? Let's see. So, man, I'm sorry. Excuse me. Excuse me. All right. Let's say that we have two complex numbers, W and Z. These two are complex numbers. And we're trying to find W over Z. Remember, this is a division. It's a fractionary, but also a division, right? So how much will be W over Z? All right. We are going to use the conjugate of Z. There was a reason why I explained the conjugate before. We're going to use the conjugate of Z. So no matter what is the denominator, we are going to find the conjugate of the denominator. All right? And how are we going to find it? How are we going to use it? I'm sorry. How are we going to use that conjugate? Simple. We're going to multiply up and down by the conjugate of the denominator. No matter what the denominator is, we're going to multiply up and down by the conjugate of the denominator. Why is this possible? Because this is the same number, so this is a 1. Whatever divided by the same whatever is 1. So we are effectively multiplying the division by 1. So we're doing nothing. Neat trick. Neat trick. All right, here is an example. Everything in math is a lot easier with examples. Yes?
¿Y siempre va a ser con el conjugado del denominador?
Yes, my friend. No matter what the denominator is, multiply by the conjugate of the denominator. Yes. If you multiply by the conjugate of the numerator, then you have mistakes, all right? You can do that. You can do that if you want to do other things, other operations with complex numbers. But for division, with the conjugate of the denominator. All right?
Listo, profe. Gracias.
Some examples. All right, brother. No problem. All right, some examples. Let's try to divide these two complex numbers. Oh, wait. Are these two complex numbers? Because we know 2 minus 3i is a complex number. We know that. 2 minus 3i is a complex number. But how about the 9? Is the 9 a complex number? In the chat, please. Is it or not? Ha, Richie, my man. Beautiful, brother. Yes, sir. Ethan, you got it right as well. Yes, 9 is a complex number. 9. Even though it looks like it is missing the imaginary part, it is right there. It is 0i. So the complex number will be 9 plus 0i. So we have a division of two complex numbers, 9, right? 9 plus 0i. Beautiful. So how do we divide these two complex numbers? The solution. We're going to take the number and multiply up and down, multiply by the conjugate of the denominator. Look, the denominator was 2 minus 3i. So the conjugate is 2 plus 3i. and multiply up and down by the conjugate. What we said here, this is exactly what we said here. Multiply up and down by the denominator, I'm sorry, by the conjugate of the denominator. Here, up and down by the conjugate of the denominator. From here, all we have to do is do algebra. We know how to do these multiplications, right? 9 times 2 will be 18. And 9 times 3i will be 27i. Just a regular multiplication. Down, we can use FOIL, right? This is a multiplication of complex numbers. We can use FOIL. So 2 times 2, 4. Then inners. And then, what was that? FOIL, outers. So 2 times 3i, 6i, right? Then inners. Negative 3i times 2, negative 6i. And then last. So negative 3i plus, times positive 3i, negative 9i squared. Remember that I squared is a negative 1. So we have, these two are canceled, and we have 4 minus 9 times negative 1. Remember, the I squared is a negative 1, right? If we do this operation, the negative and the negative will be positive. And 18 plus 27i over 13. Now, we knew this from the beginning, right? We knew this. This is a complex number multiplied by its conjugate. So all we have to do is a squared, 4, plus b squared, 9. We didn't have to do all this process, right? We saw it in the board. Beautiful. But now, we have to take into account one last step. Every complex number that we have has a real part, then an operation, and then an imaginary part, right? The real part here is 2. The imaginary part is negative 3. Which is wish here. This should be a complex number, which should have one real part and one imaginary part. But this thing is a division. This thing is still being divided by 13. What do we do? Absolutely simple. We're going to split this into 2. The 18 will go with the 13, right? The 13 will divide the 18, and the 13 will also divide the 27, like this. 18 over 13 plus 27 over 13. The 13 is going to go on both sides. The denominator on both sides. The operation in the middle, the operation of the complex number, is going to be the one in between the fractionaries. And now from here, we can see clearly which are the real part and the imaginary part. The real part will be 18 over 13. The imaginary part will be 27 over 13. Now we can see which is the real and which is the imaginary. And this is important because you guys will take quizzes and will take exams and classwork where the question will ask you, write the real part and write the imaginary part. So you need to know how to split these two. Here, a plus bi, which is the standard form of every complex number. Another example, how about this one? 1 minus 2i over 4i. Is this a complex number or not? Yes, it is, right? Yes, it is. The real part will be 0. We have 0 plus 4i. Do we or not? Okay, so we have a complex number here. How do we divide these two? Simple. We are going to multiply up and down by the conjugate of 4i. Now, before I show you what is the conjugate, go ahead and tell me in the chat, which do you think is the conjugate of the denominator here? Again, which do you think is the conjugate of the denominator? Beautiful, guys. I know a lot of you are not answering, but the 7 of you who did are correct. The conjugate, since this is the imaginary part, the conjugate will be the imaginary part with the negative change, with the different sign. So, yes, you guys, you got it correctly. Multiply up and down by the conjugate of the denominator, negative 4i. Negative 4i. Remember, this is the imaginary part. It's a positive number. So the conjugate, we have the negative imaginary part. Beautiful stuff. From here, do the multiplication. So 1 times negative 4i will be negative 4i. Negative 2i times negative 4i. All right, negative and negative will be positive. 2 times 4 will be 8. I times I will be I squared. And now the denominator, 4 times 4, that will be 16. Positive and negative will be negative. And I times I will be I squared. That is easy. Now, we have two events in which we have an I to the second power. That, just like in here, I to the second power is negative 1. So we have negative I plus A times negative 1. And down, we have negative 16 times negative 1, which we can solve for, of course. Negative 4i plus and minus will be negative, right? Plus and negative, so negative 8. And over 16. Yes, Richie, you got it correct, brother. Beautiful. Now, next time, Richie, just to make things a little bit clearer, put in parentheses the ones that are in the numerator before doing the line of the denominator. Something like this. Take a look at the chat, please. Let me write it. Sorry. And then here. Like that, all right? Can you see it? Like that. All right? Now we know that the entire of the parentheses is being divided by 16. Because in your answer, the negative 8 was the only thing being divided. All right, brother? But yes, you got it correct, dude. You got it correct. All right. From here, let's just give it a little bit of order. Look, in our experience, we know that the real part goes first and the imaginary part goes second, right? But in this example, the imaginary part is first and the real is second. Now, this is not a mistake. We can leave it like that. But let's try to be a little bit more organized. We can give it order, right? So we can change the values. Negative 8 first and negative 4i second. Now, from here, just like we did in our first example, split the values of the 16. The 16 would go under the 8, and the 16 will go under the 4. Just like this. Negative 8 over 16 minus 4 over 16. Did we finish? Sarah Jimenez will say, no, teacher, you didn't. Because Sarah had the right answer from the beginning. We can simplify this too. 8 and 16 can be simplified. And 4 and 16 can be simplified. So 8 and 16 will be negative 1 over 2. 4 and 16 will be 1 over 4. And then the I. This will be the final solution of our division. This is the number in standard form. We have the real part, negative 1/2, and we have the imaginary part, negative 1/4. Beautiful, guys. Just like that, we know how to divide complex numbers. Of course, I have another 2 examples, just in case you want to practice a little bit more. So let's try to divide these 2 complex numbers. I'm going to do these ones a little bit faster. Solution. Take the number, multiply up and down by the conjugate of the denominator. Remember, always the conjugate of the denominator, right? From here, do the multiplications. Now, I'm not going to do the multiplication in the denominator because we know from the trick we learned, we know it will be 5 to the second power and 12 to the second power, an addition in the middle. 25 plus 144. Unfortunately, that trick only works for the denominators. I do have to do the multiplication on the numerators always. Always. So 1 times 5, 5. 1 times 12i, 12i. 4i times 5, 20i. And lasts, 4i times 12i. So positive and positive, positive. 4 times 12, 48. I times I squared. From here, try to do the algebra that you can. Remember, this 48 will be negative 48 because we have an I square. So we have positive 48 times minus 1, right? This is negative 48. So we have 5 minus 48, negative 43. 12i plus 20i, this is 32i. and the denominators are 169. Split these two, and there we go. There we go. We have our solution. Last example I'm going to show you guys. Two complex numbers. Solution. How do we divide these? Simple. Multiply up and down by the conjugate. The conjugate of the denominator, of course. Here, the denominator was 4 minus 3i. We have 4 plus 3i then. Up and down. By doing the multiplication, we know the trick in the denominator. 4 times 4 is 16. 3 times 3, 9. That's simple. But on top, I do have to do the multiplications. We do have to do FOIL. So 2 times 4, 8. 2 times 3i is 6i. Negative 3i times 4, this will be negative 12i. And negative 3 times positive 3, negative 9, right? And I times I squared. This 9 will be positive because of the I squared, right? We have negative 9 times minus 1. So this will be positive 9. So 8 plus 9, remember to do like terms, 8 plus 9 will be 17. And 6 minus 12, negative 6i. Split the denominator. Of course, the denominator was 16 plus 9, which is 25. Split the denominator, and we have our final solution, guys. From here, this is how you divide complex numbers. Now, what I want you to do, guys, is to practice. You can listen to my voice all you want, but if you do not practice, then you're going to have difficulties. So what I want you to do, guys, is to please go ahead and log in to Alex and try to do the classwork number 3. All right? Now, I am going to stop the recording of the class right now, but if you guys have any questions, you guys can ask me, and I will record it again, all right?